Hello, welcome back to the channel again. Today let's look at another challenge. Today's challenge is find largest value in each tree row. Basically, row means like a level in a binary tree. So given the root of a binary tree, return an array of the largest value in each row of the tree. In each row here, it means we have levels, right? So we have a binary tree. We have at most two children, left children and right children, and each child has at most two children. So the problem statement is for each tree we have to find the largest value in each level, right? This is a level 0, this is level 1, this is level 2, because this is 0 indexed. So in the level 0 we have just one element, right? That's a root, and we have two children, and there's in level 1, so it has two values. In the level 3 there are three values, right? So these are the constraints. The number of nodes in the tree will be in the range from 0 to 10 power 4, and these are the node values from minus 2 power 31 to plus 2 power 31 minus 1. So let's look at with some examples. So this is the same tree. So we have initially we are given the root, and level 0, level 1, and level 2. These are the levels. So this is a level 1, level 0, level 1, and level 2. So for the level 1, it has only one element. It's also the root. So we are asked to return the maximum element in each row. Basically, in the first row we have a single element, so the maximum of this will be 1. And the second row we have two elements, 3 and 2, so the maximum from this 2 is 3. And from the second row, you can say the third row, and so we have a 3 element, 5, 3, and 9, and the maximum of this is 9. So all we need to do is resolve. So we need to return 1 from the first level, and 3 from the second level, and 9 from the third level, right? So what we need to do, so this is easy BFS. We can do level order traversal and with queue data structure. So let's look at this, how we're gonna do this. So initially we're gonna add the level 1, which is a root, and level 0, which is a root. We're gonna add this to the queue, and we pop it, and here we initialize result as empty list, let's say, and we add this first element in the level 0 to the queue, and we pop it. And after we pop it, we see, then we look at we iterate through this level and see there is only one element in the level. So that's maximum is basically the 1. And this, after we add this this maximum, this is it was level max was minus infinity, so it will be 1, right? And after that we add the left and the right child to the queue. So basically 3, let's just look at the different color, 3 and 2. Then this will be level 1, and for each one of them we repeat again. We pop 3. So let's say we pop 3, and after we pop 3, then 3 has 2 children. So this 5 and 3 we add to the, let's look at different color. So 5 and 3 we add to the queue, and initially then when we are traversing, looping through each level, we set this level max again minus infinity, and the 3 will be level max. Then we pop 2 and we check if this level max, the second 2, right, this 2, if 2 is bigger than the level max was initially 3, so we're gonna get the maximum element of 3 and 2, which is gonna be 3. So this will be added to the output, and after we pop 2, we also need to add its child to the list, to the queue. So now we start popping this level 2 one by one. So we pop 5, and we see, does it have any right and left child? No. If there is no right and left child, we don't add anything to the queue. Then we pop 3. So we'll just we see if the 3 has any child. It doesn't have any child, so we don't add anything. Then we pop 9. So for each one of them, initially for each when we loop through each level, we initialize level max minus infinity, and when we pop 5, basically then we update this to 5. Then after we pop 3, which is bigger, 5 or 3? 5 is bigger, so we basically keep the 5. Then after we pop 9, then we compare 5, a level max is 5, so we compared with the new element 9, so then we update 9. So we add this 9 to the result. So basically then at the end we need to return this result. So this is a simple level order traversal with the BFS. It can also be done with DFS, but this solution is simple. So we will look at the code now. So this is a code. We initially check if the root is none, then we return the empty list because there is nothing to return. Then we add the root to the queue in this line. We add the root to the queue. Then we initialize output to be an empty list. Then we check if the queue is empty. We get the size of the queue. Then we, for each level, as I showed in the example, for each level, we initialize level max to be minus infinity. Then for that level, we loop through that level. Initially, we get the size. So if the size is 2, so basically it's we loop from 1 to 2, right, or 0 to 1, and we pop that node from a queue. Then we check if this level max, we compare this level max with the node value, and whichever is bigger, we get that one. Then after we process that node, then we need to add if the node if left child exists, we need to add that to the queue. If the right child exists, then we need to add to the queue. Then after processing each level, then we need to add this level max to the output, and at the end we need to return the output. So yeah, this is a solution for this problem. This is it says this is a medium problem, but once you are comfortable with BFS level order traversal, basically with the queue data structure, and this is something easy to solve. Okay, yeah, thank you for coming back to the channel, and please subscribe and give comments, or if you have any questions, yeah, please write in the comments. Thank you very much.